Dear students, in this chapter on control of microorganisms in foods, part 1, you will learn about the principles and methods of food protection and preservation, which includes physical methods of food preservations like dehydration, freezing, cold temperature and heat treatment. The standards for the number of microbes that is permitted in various foods are specified in our country by Food Safety and Standards Authority of India, that is FSSAI. Every company dealing with food needs to take their approval and adhere to their conditions laid by them. This is mainly to prevent the spoilage of food and to further take care of the consumer's health. They also lay down the standards for the containers, preservatives, nutritional conditions, contaminations and storage. The details of FSSAI law will be dealt in another chapter. Introduction. Nature provides protective covering around the food. It may be in the form of a shell of a nut, dry skin of cereals or thick skin of fruits and vegetables. In animal based foods, the shells of eggs, the rubbery skin or fat layer on meat or fish provides the protection. These protective coverings also prevent or delay microbial colonization and further decomposition. The aim of food protection and food preservation is to prevent contamination and spoilage of food. A number of food preservation methods are used today, has its origin dating back to ancient times. One of the most important ways of preventing food spoilage is by a good handler's hygiene. This includes a set of practices that should be followed by all the personnels involved in handling food at any stage of the food supply process. Food handlers' hygiene in both retail and commercial premises where food and drink is sold to the customers is of critical importance. The same principle should also be practiced at domestic premises. The importance of good hygiene and handlers' hygiene is to prevent the food contamination and spread of disease, to ensure good health of people eating the food, to protect the health of food handlers. All the food handlers should avoid bad habits such as scratching, touching the hair, nose or mouth, having unclean hair, unhealthy and long fingernails. They should also refrain from smoking, coughing or sneezing in the food handling and preparation areas. They should be healthy and should not be carrying any contagious disease like skin infection, diarrhea or sore throats. They should always wash their hands before they enter the premises where food is prepared or handled and after using the toilets. Some of the general principles for preventing food contaminations are: water used in the food preparation should be of a good quality and adhere to the standards specified by FSSAI. All the utensils must be kept clean and covered. All surfaces that come in contact with the food should be well cleaned. The area used for storage, preparation and serving of food should be free of pests, rats and insects. All types of prepared food should be clearly labeled and covered. Food and the utensil should be kept separate from chemicals and poisons. The cloths and handling aids that come in contact with dishes and utensils and that are used to cover the food need to be changed daily and washed in hot water before use. Food preservation means techniques that allow food to be kept for a specified extended period of time without losing nutritional quality. They should also prevent the growth of unwanted microorganisms. The three basic objectives of food preservations are: preservation of contamination of food from damaging agents, preservation or delay of growth of spoilage of microorganisms, delay of enzymatic spoilage due to the presence of naturally occurring enzymes within the food, that is self decomposition. During storage or preserving food, the conditions required for the spoilage system has to be removed. Like we humans, microorganisms also need food and water. Further, They also need a suitable pH and temperature to grow. Hence, food preservation techniques aim to target and limit these requirements. Food preservation depends on the method which effectively manage the microbial content of foods. They should also alter or delay the activities of enzymes in the food. These techniques may be applied separately or in combination. Thus, the aim of food preservation should be to prevent contamination in the first place, to reduce the population of contaminants and to prevent microbial growth. Food can be damaged either by insects, animals or by mishandling. The damaged portion are then exposed to microbial attack. Therefore, care should be taken to minimize any damage to the food. The pre-processing of food preservation is divided into 3 stages of careful handling. 1. Proper packaging. Number 2. Quick and effective transportation. Number 3. Providing good storage facilities, that is silos for grains and cold storage for fruits and vegetables. Once the food ingredients, that is the raw materials, are properly handled and managed, the next step is food preservation. Food industry adopts several aseptic methods to prevent the contamination of food during processing. Packaging of food is to prevent contamination. The packaging material may range from simple wrappers to hermetically sealed containers of canned food. Polyethylene bags and moisture proof wrappings like metal foils, mixture of plastic, paper and foils are commonly used. Various industries determine the process of food preservation based on their requirements. For example, in the canning industry, the microbial load determines the temperature required to process. This is better known as aseptic canning. In the dairy industry, the quality of milk is judged by its bacterial content. Some of the methods adopted to achieve good processed food are complete removal of microbes. Filtration is a method used for the complete removal of microorganisms. This method can be successfully applied only to clear liquids. Example, water, fruit juice, beer, soft drinks and wine. The filters used are made up of asbestos pads, unglazed porcelain and similar materials. The filters are sterilized and made bacterial proof before they are used. The liquid is filtered by passing through the filters under pressure, inhibiting the growth and or activity of microorganisms. This may be achieved by storing at low temperature or drying or by providing anaerobic conditions by using chemicals. When anaerobic or absence of oxygen conditions are created, most of the anaerobic organisms die. The spores may survive, but will be unable to multiply in the absence of oxygen. This principle is used in canning and in packaged foods. Holding the food material at low temperature in cold storage slows down and sometimes prevents microbial activity. Drying of food is a very effective method for avoiding spoilage of food. All microorganisms need moisture and they cannot flourish in the absence of moisture. Certain chemicals like sodium benzoate and potassium metabisulfate are used as preservatives, but they should be used within the prescribed limit, as any excess usage may result in poisoning. By killing the organism using heat or radiation. The most common of all methods and used from ancient time is heat processing. In radiation, gamma rays or high speed electrons are used to destroy the microorganisms. Such radiations are known as ionized radiations. This topic will be dealt in part 2 of this chapter. Prevention or delay of self decomposition of food. This is commonly carried out by destruction or inactivation of food enzymes by blanching. Blanching is a process of dipping the whole food material in boiling water for a short period of time. This process inactivates plant and microbial enzymes, which if not inactivated might cause toughness and change in color. Most of the plants and animal tissues contain enzymes which are active at room temperatures. An increase of temperature by 10 degrees Celsius doubles the rate of the chemical change. Rancidity of fat is an example of undesired oxidation, which leads to the deterioration in the flavor of foods. Oxidation also leads to the loss of ascorbic acid, an important vitamin required by mankind. These endoenzymes softens the tissue or fibers. The surface of cut fruits are oxidized and they turn black, thereby changing the color, texture and nutritive value. Fruit and vegetables are blanched before freezing to inactivate the oxidative enzymes. Blanching is carried out using hot water or steam, and the time duration of treatment applied varies with the kind of food. Normally, brief heat treatment is supposed to reduce the number of microorganisms on the food, enhance the color of the vegetables such as peas and spinach. They also prevent damage caused by mechanical means, insects and animals. Avoiding of recontamination. Hygienic storage of the finished product, aseptic processing following of HACCP, GMP, ISO 9000, TQM needs to be a part of the production line. Some of the methods in food processing in this are canning. Canning is a process in which over 100 degrees Celsius is used for killing all spoilage organisms and their spores, as well as inactivating the enzymes and sealing in sterile airtight containers. The packaging material for canning can be tin or glass. In this process, the food is sterilized. The objective of sterilization is to destroy all the microorganisms in the food material. This prevents decomposition of the food, which otherwise makes it unattractive or unedible. Sterilization also prevents any pathogenic, that is, disease producing organism from contaminating the food. Pathogenic toxins may be produced during storage of food if certain organisms are still viable. Microorganisms are destroyed by heat, but the amount of heating required for the killing of different organisms varies. Also, many bacteria can exist in two forms, that is, the vegetative or the growing form and the spore or the dormant form. The spores are much harder to destroy by heat treatment than they are in the vegetative forms. It has been found that microorganisms including Clostridium botulinum are destroyed by heat at rate which depends on the temperature. Higher temperature kills spore more quickly. At any given temperature, the spores are killed at different times, as some spores are more resistant to heat than other spores. If a graph is drawn, the number of surviving spores against time of holding at any chosen temperature, it is found experimentally that the number of surviving spore falls almost to 0. Experimentally, it has been found that if the logarithm of T, the thermal death time, is plotted against the temperature, a straight line relationship is obtained. This is shown in figure 1. We can then write from the graph log T minus log F is equal to m into 121 minus T is equal to log T divided by F, where T is the thermal dead time at temperature T, F is the thermal dead time at the temperature 121 degrees Celsius, and m is the slope of the graph. The D value of an organism is the time required in a given medium at a given temperature for a 10-fold reduction in the number of organisms, and the Z value is a measure of the change of the D value with varying temperatures. It is possible to choose values of F and Z to suit specific requirements based on contaminating organisms. Basically, heat treatment can be classified into 3 categories. Pasteurization, that is temperature below 100 degrees Celsius. Pasteurization is a heat temperature that kills part of the microorganism present in the food using the temperature under 100 degrees Celsius. The temperature range is normally from 65 to 75 degrees Celsius. There are 2 ways of pasteurization: HTST, that is high temperature short time pasteurization. Food product is heated at high temperature for a short time, For example, milk is heated to 72 degrees Celsius and held for 15 seconds. Second one, LTLH, that is low temperature long time pasteurization. Food product is heated at a lower temperature for a longer period of time. For example, milk is heated at 62.8 degrees and held for 30 minutes. Boiling or heating at about 100 degrees Celsius. Most fruits and vegetables can be preserved for a longer period of time by applying heat at about 100 degrees Celsius. Inherent enzymes which initiate self decomposition can be destroyed after boiling at 100 degrees Celsius. This process is called as blanching. Sterilization, temperatures of 100 degrees or above. This is a process that all the microorganisms are being killed at high temperature or radiation. The time and temperature necessary for sterilization varies with the type of food. Few examples are listed in table 1. Time and temperature required for sterilization of various foods. Type of foods, temperature, duration. Fruit and tomatoes 100 degrees Celsius 30 minutes. Vegetables 116 degrees Celsius 30 to 70 minutes. Milk ultra heat treatment, we call it as UHT 135 degrees Celsius not less than 1 second. However, the type of food determines the type of treatment and not the type of contaminating organisms. For example, if the food is overcooked, major changes occur in texture, flavor and nutritional quality, making them unpalatable. Use of low temperature and cold preservation. Low temperature can lower the rate of chemical reaction and the action of enzymes. Generally, freezing can prevent the growth of most foodborne microorganisms, and the usual temperature for cold storage is between 4.5 to 7 degrees Celsius. Refrigeration temperature lowers the growth rate of microorganisms, and chilling can slow down the enzymatic and microbial changes in food. For frozen food, it should be stored at about below minus 18 degrees Celsius, where the enzymatic and the microbial changes may be stopped or is extremely slow. Dehydration. Dehydration or dehydration of food as a method of preservation has a long history, especially in Chinese food. Mushrooms, dried shrimps and salted fish are some of the typical examples. Both drying and dehydration means the removal of water. Drying usually describes the process of drying under sunshine or in open air. The other term dehydration usually describes the removal of moisture by applying artificial heat current under controlled conditions. Some of the differences of drying and dehydration are listed in table 2. Differences between drying and dehydration. Dehydration, sun drying. A faster process under controlled condition, a slower process under open air. Hygienic conditions not dependent on the weather, conditions with little hygienic control not possible in cloudy weather or rainy days. Investment on machinery and processing cost is needed. No machinery and processing cost is needed. Use of preservatives. Preservatives serve as antimicrobials which prevent or slow down the growth of molds, yeast and bacteria. By preventing the growth of molds, yeast and bacteria, preservatives can improve the safety of food as well as prevent the wastage of seasonal surplus by making it long laster on the shelf or in the fridge. An ideal preservative should meet the following criteria. It can inhibit the growth of a wide range of microorganisms, should be non-toxic to humans, should not be expensive, should not affect the flavor, taste or aroma of the food product, should not be inactivated by the food, should not promote the development of resistant microorganisms, should kill rather than inhibit the microorganisms. Some of the common preservatives used in food are listed in table 3. Some common preservatives. Preservative, target organisms, application in food. Sulfides, yeast and bacteria, dehydrated fruits and vegetables, wine, juice, sausages. Sodium nitrate, bacteria, meat and meat products, propionic acid, molds, breads, cakes and cheese. Sorbic acid, molds, cheese, cakes, salad dressing and wines. Brining and sugar solution preservation. It means the usage of salt and sugar for food preservation. Sugar binds moisture and thus can preserve food by preventing the growth of microorganisms. However, sugar needs to be used in high concentrations, that is 65% or above. Products such as jams and jellies are preserved by using sugar. Most of the candies, both hard and soft, are preserved using sugar. Salt in high concentrations, that is above 15% to 20%, can prevent the water from being available for bacterial growth. This process is known as reducing the water activity, that is abbreviated as AW. It can slow the growth rate of bacteria and thus the food is preserved. Salt can be used in brine, that is salt water, or applied to food directly. Most common salt used for food preservation is sodium chloride or common salt. Pickling. It is a process in which use of acids, that is vinegar or citric acid, spices, brine are in combination, that is hurdle technology, which will be dealt in part 2 of food preservation. This treatment lowers the pH and thus inhibits the growth of many microorganisms. It is more effective against yeast and bacteria than molds. About 20% vinegar, that is acetic acid, prevents the spoilage of most products. It is used in the preservation of pickles, sauces and chutney. Another acid, citric acid, is also used in the preservation of certain fruits and vegetables. Products of jam, jellies, squashes may contain citric acid. It lowers the pH of the food products and can prevent the growth of molds. Conclusion. In this chapter, we try to understand the commonly used process of food preservation. Most of these techniques are widely used in home or cottage industry levels with minimum machineries. The main intention are to see that the uncooked food, that is raw materials, are handled carefully. Further, the basic principles of hygiene are to be practiced. Methods like cooking at high temperature and keeping them in closed containers, storing the cooked food at low temperatures are common practices at home levels. Understanding the D and the Z value required for preventing the contamination and the temperatures to which the food can be taken without losing its organoleptic characters are important. Many of the foods that we use in our common day-to-day life are processed in these manners. Example, milk, papad, pickle, jam, etc. Dear viewers, the more modern technologies that the industries adopt to handle large quantity of food will be taken up in part 2 of food preservation. Thank you.